In this video, we're going to be working on the parent function of absolute value, and we're going to look at different translations and what those equations would look like. So we're going to make a foldable that when we fold it is going to end up looking like this, so that when we open it up, we can see the different information that's in there. So if you haven't already, when you print out the handouts double-sided, you will notice that you have this one on the very top. You're going to put that on the very bottom. Try to get my camera to show the whole thing. And then you're going to take the one that says reflection, and you're going to put it just such that it's right above that absolute value. And then the stretch compression, so that it's just above the reflection. So you're going to have your papers on the bottom look like this. You're going to take all three of those from the top together, and you're going to bring it over so that the edge of this vertical translation is just touching the word of stretch. Just try to make sure everything's lined up nicely. It might get off a little bit, that's okay. And then you're going to go ahead and crease it at the top. So now that you have that, you have your foldable all ready to go. We can glue it later when you get to class. I'll show you how to glue that together. Okay, so for this video, we're going to talk about the parent function, the horizontal translation, and hopefully the vertical translation. So you'll need this, and I'm also going to show you how to do things on your calculator. Okay, so here we have the equation of the function, and because it has these absolute value marks here, this makes it an absolute value function. I'm going to go ahead and just zoom in to that very top one. So the name of the function is absolute value. And you can remember absolute value because the graph is going to make the shape of a V, as in value. Okay, so we have some vocabulary here: vertex, axis of symmetry. Now, parent function means just basically the bare minimum you need to have the absolute value. So if we think of parents, they're the starters. There's the one who start the family. It's the actually very bare minimum you need to have that function. So let's put down here bare minimum to have the function. Okay? So if we notice, what's the bare minimum we need to have the function? The bare minimum is we have to have our absolute value, and we have to have our variable, which in this case is x. Remember, this is nothing more than y. This is the same thing as saying y. And it's telling us this is a function that depends on the input of x. So let's go ahead and graph this. We're going to do it via the calculator just to save time. We're going to go to y equals, and we're going to put absolute value of x. So remember I said f at x is the same as y. That's why I can go to y equals. So where's the absolute value? If you go here to math, and then you scroll over to the top to numbers, you see ABS. That means absolute value. You push enter, you get your absolute value, and then put in your variable x. So when we go to graph this, we're just going to get a sneak preview of what this looks like. So you can see that it drew a V. Always look at what the function looks like before you graph it. So now I'm going to go to my table, and it's nicely balanced on both sides of that 0, which is kind of nice. I am going to start at 0, 0, and then I have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and so forth upwards. So I'm just going to put those point values there. But then I also have negative 1, 1, negative 2, 2, negative 3, 3. So here's my parent function that I'm drawing in right now. So the parent function is basically just the bare minimum you need to have that function. So because I'm talking about this function, which is my parent function, I'm going to go ahead and make these lines solid. And you will see on the graphs on the inside of this that there is a dashed parent function, because that's what we're comparing things to. Okay, just like children are compared to their parents, all of our translations we will compare to our parents. So there's some important parts here. Right down here, let me do this in a red color. Right here, this very bottom point is called our vertex. And for most of our parent functions, because there are many different functions, our vertex is usually 0, 0. So here, our vertex is at 0, 0. So now there's this thing called an axis of symmetry. So symmetry means that I have, if I were to fold this in half, this side would lay on this side. And in fact, you can try that, and you'll see what I'm talking about. So the axis of symmetry is where I could fold my function in half, and it would be the same on the left and the right. It would fold over. It's balanced, in other words. It's balanced on the left and the right. So you can see I did this as a dashed line. This here is my axis of symmetry. And it's an equation. That is where x equals 0. So my y-axis, remember, is a line, y equals 0. In this case, my axis of symmetry also happens to be my y-axis, which is the line x equals 0. So for axis of symmetry, I'm going to write x equals 0. So now I'm going to be comparing everything to my parent. Let's look at horizontal. If you notice horizontal, I have something that looks like the x-axis. So that means that my function is going to be translated or moved, transitioned, either to the left or the right, depending on how that equation is written. Okay, so let's go ahead and open up our foldable. Let's deal with the parent function on, the function on the left. So remember, my parent function, notice this is absolute value. So my parent function is f at x equals the absolute value of x. I got that from the front. I could have written this, y is equal to the absolute value of x. Both of these mean the same thing. So let's look at what happened here. Notice here, now I have a number inside the absolute value. So I'm going to look inside the absolute value here. I have an x minus 4 inside, so here I'm going to have an x minus 4. On the outside, there's nothing. So since there's nothing on the outside, I'm going to write, trying to figure out what color I want to put this in, I'm going to write this as a plus 0. Okay? Because there's nothing out here, 0 has no value. So looking here, I'm going to get my vertex. This here is like my h, and this is like my k. I'm going to write this like this. This is like my h, and this is my k. Which means then that my vertex is 4, 0. Okay, I'm going to show that to you in just a second. We're going to do this on the calculator before I get ahead of myself. Okay, so let's look here. This was my parent. This is what we graphed on the previous side. So now I'm going to go to 4, 0, which is right here. So now my function's beginning here. So let's go ahead and open up the calculator, and we see there was my parent. Okay? But let's go ahead and put in minus 4 here. And if we look at the graph, we can see that it definitely shifted off to the side. It shifted to the right 4. So if I go to my table, I can put in those values of points. I'm just going to do that fairly quickly here because the video is getting a little longer than I want it to. So if you notice, everything, it's still kind of parallel to this. So I could follow the points on my calculator, which if you are trying to follow along, I highly recommend you pause the video and then graph that yourself. So let's think now. What is my vertex? Well, remember my vertex is here. No, I'm sorry, before I do that, I'm trying to rush this video to make it not so long, but I guess it's just going to be what it's going to be. So this here is the function that I'm actually concerned about, the one that's solid. Okay, I'm going to mark this for you. This one here is my parent. Okay, and this one here is my actual function. So if we look at our vertex right here, that's my vertex, and my vertex is 4, 0. Just what I predicted it would be here. Okay, so my axis of symmetry, again, is going to always go through that vertex. So my axis of symmetry is right here. Now remember, I'm only concerned about this function. I'm comparing it to this one. So my axis of symmetry is here, and that's where x equals 4. This is a line x equals 4. So my my axis of symmetry is x equals 4, and my transformation is, well, what did it do? From here to here, it moved, my vertex moved left 4. Right 4. So this went right 4. So that's the simple transformation. Inside is going to tell me whether it moves left or right, and then we will look at another example in the next video because this video has gotten too long.